Good morning, guys. Today we are going to be learning about 6.7, exponential growth and decay. You guys will be able to use exponential functions to model situations and make predictions. So our previous lesson, we learned about graphing exponential functions. So like an exponential growth function looked something like this. And an exponential decay function looked something like this. Now, when we have these sort of equations, they usually have something to do with like real life things, real life problems. So we're going to do some of those sorts of problems today just to like figure out how things plug in and what this actually solves for. It's not just random information, it's actually helpful information. So we have this formula here. This occurs when a quantity exponentially increases over time. So our formula is y equals a times 1 plus r to the t power. Now what do a, r, and t stand for? A is your initial amount, so that's how much you start with. R is your growth rate, and t is your time. Now, growth rate you want as a decimal. Not as a percent. So you'll see why that matters here in a second. The first question says the original value of an investment is 1,400. So guys, that is your initial amount. That's A. The value increases by 9%. We want to write this as a decimal. If you recall, to write a decimal from a percent, you have to move your decimal place 2 times. So our rate is 0.09. You must do that. If you try to type in 9 there, it's going to be a really crazy wrong number. Use an exponential growth function to find the value of the investment after t time 25 years. So now that we know what a and r and t are, it's actually really quite simple to plug this information into your equation. And the only really big thing that you've had to change based on what words are given to you is this to your decimal from the percent. Okay, everything else plug straight in. From here, we're going to type this into Desmos to find how much it has grown over 25 years. So when we get back to school, you can also use your blue calculators, and the blue calculators are what you'll have to use on a test. So I would get used to practicing typing this in, okay? Desmos is a little more straightforward because I can just type it in exactly how it looks. In your calculator at school, you'll have to do your addition. So here, let me redo this. You'll have to do your addition. Then you'll have to take that answer to your 25th power, and then you'll have to take that answer times your initial amount. See how you get the same number? Your blue calculator won't want you to type it in all at the same time, I guess is what I'm saying. So break it up into the different parts, solve in your parentheses, then do your exponent, then do your multiplication, just like PEMDAS tells you to do. Okay, so back here, we can write our answer down. So we have $12,072, and then since it's money, we have to round it to 2 decimal places, so 31 cents. Okay, let's just keep going. Next, the cost of tuition at a college is $12,000. And it is increasing at a rate of 6%. Switch that to a decimal, 0.06 each year. Use the exponential function to find the tuition cost after 4 years. So if any of you end up going to college, and if they have a specific rate that the tuition amount increases, you'll be able to figure how much you'd be paying in your last year. So I'll show you using this calculator this time. This is closer to our blue calculator. Oh, first let me write it out though. We have y equals 12,000 times 1 plus 0.06 to the 4th power. Notice all I've done is plug information into this formula up above. Okay, now I'll use this calculator. So we have 1 plus 0.06. Now we have 1.06, sorry. Let me figure out how this works. To the 4th power. I think that's right. Let me check. Times 12,000. Yes. So, once you plug it in, like this, or if you use Desmos, that's fine too. You'll get that your last year of tuition will cost $15,149.72. If you notice, these are all very, very similar to that. We're going to try one more of this increasing. I'm just going to pick a random one. Let's do question 4. So annual sales for a company are 149,999 and are increasing at a rate of 6%. So we have to rewrite this as a decimal, 0.06 over 7 years. Use an exponential function to find the annual sales after 7 years. If it helps you, you can go through and underline all the numbers that it gives you, so that way you can more easily solve. Now we plug in our information. We have y equals our initial amount times 1 plus our rate to the power of time. Plug into my calculator again. I know this is 1.06, so I'm going to skip the step of doing the addition. I can do that in my head pretty easy. That's to the 7th power. And then I multiply that by 149,999. And this annual sales after 7 years should be up to $225,543.04. Okay, on the next side of the page, we have exponential decay. You'll notice your information is super similar, other than instead of adding here, you are subtracting. A and R and T all still stand for the same things. Initial amount is A. R, instead of being growth rate this time, it's decay rate, but it's just the rate. You write it as a decimal. And then T is still time. So let's jump in with question 7. The population of a town is decreasing at a rate of 1%. So that is our rate. We have to write this as a decimal, so 0.01. In 2000, the year 2000, there was 1,300 people. Use an exponential function to find the population in 2008. Now guys, that is 8 years. You can count. You can do 2008 minus 2000. That one is a little trickier because you're not plugging in the number 2000, okay, or 2008. You are plugging in how much time has passed. So, we'll now put this into our formula. Y equals our initial amount times 1 minus 0.01 to the time 8. 8 years has passed. We're going to see how many people are left in this town at the end of 8 years. So, use my calculator. We have 1 minus 0.01 to the 8th power times 1,300. Now, you can't have a part of a person, so we do have to round this. There will be about 1,200 people left in the town after 8 years. Oh, this next one's a good one. Some of you probably are looking at getting cars. The value of a car is $18,000. That's your initial amount. And is depreciating at a rate of 12% per year. So if we move our decimal place 2 times, that's 0.12. Use the exponential function to find the value of the car after 10 years. So guys, cars are almost always a depreciating asset. So the more you spend on the car, you technically sort of lose money other than the value of driving it. So be very careful when you are buying a car that you don't overspend and end up in more debt than you should. So we make our formula here. So we have 18,000 times 1 minus 0.12 to the 10th power. And now I'll plug it into my calculator. So 1 minus 0.12 to the 10th power times 18,000. Oops, I put too many zeros on and I don't think it'll let me back up. Let me try that again. 1 times, nope, 1 minus 0.12 to the 10th power times 18,000. Okay, so after 10 years, your car is only worth $5,013.02 approximately. So, if you think it's worth $13,000 to drive your car for 10 years, great. Just know that it won't be worth as much as when you bought your car. Okay, let's do one more. Let's do question 10. An investment of $8,200 loses value at a rate of 2%. So we move our decimal place 2 times, 0.02 per year. Use an exponential function to find the value of the investment after 9 years. So we have y equals 8,200 times 1 minus 0.02 to the 9th power. Plug it into my calculator. 1 minus 0.02 to the 9th power times 8,200. So your investment after 9 years will be worth less than what you put it in. That is $6,836.73. Okay, there are more examples here, but that's all we're going to do for today. Make sure you get these notes written down. Let me know if you have any questions, and I'll see you later.